Alright, so I thought I'd walk through. In a previous video, I talked about the computational mechanisms that I think can be legitimately uh, fit into an evolutionary model of psychology and all of that. Um, and there was no type two, so it doesn't line up with the Chomsky hierarchy very well. It is a very coarse grained system, right? So uh, while there's three different basic mechanisms. They don't model the mind very well. That's not what they're intended to do. But so the ones on the outside, the simplest and the most capable, um, they're pretty clearly defined as to what they do. But the middle one, it's also, I mean, it's well defined, but its range of applications is astounding. It's extremely large. So there's certainly room for like refinement and like, oh, there's a subclass of this and subclasses of the subclass. That's definitely a thing that if somebody wanted to take this and kind of work on it further, there's absolutely room. It's not a finished product by any means. But I thought it might be worthwhile to go through and look at communication systems in animals and how they relate to these mechanisms. So just to review, the simplest, they're all named after female names. The simplest is Genevieve, and all that does is, given a stimulus, it produces a response. That's it. Like a doorknob, like, you know, simple things. Simple machines. Beta decay. Uh, you know, uh, Spectral lines, orbits of planets, you know, very predictable, simple things. The second one that is is the one that has the broad range of application in cognition is Eleanor, and what she does is basically the same thing, except so you have a stimulus and you respond to it, but the responses can be programmed, right? So Genevieve, it's basically just a physical or a chemical sort of thing, like, right? It's the stimulus and the response. That's how physics works. That's how the world works. That's how you get this. Um, eh, yeah, it can't be dynamically programmed at the very least, right? But Eleanor can be programmed. So, like, your ability to read English or your ability to understand the words coming out of my mouth, that was programmed, but it is now so instant, so rapid, and so, you're not thinking about it. There isn't any higher sort of, it's basically a stimulus, your brain responds, and you understand. Like, that's how it works. That sort of a thing. But if you didn't ever learn English, then you wouldn't know what I'm saying. So, right, it's a very quick, instant stimulus response, but it's programmable. And this turns out to have like the hugest range of capabilities. And then the highest level is Emily, and she's simply the ability to handle a Turing complete instruction set. So we have the Eleanor and Genevieve are type 3. They can handle type 3 grammars. And Emily is type 1. There is no type 2 because I don't think I can justify that in evolutionary terms. I'll probably make a video about that one, but yeah. So we have two type 3s and a type 1. Now looking at so I had to make up those names because they are my own sort of invention, based on what I was seeing. It's like, okay, I'm seeing something a little bit different than what other people are talking about when they're talking about computational complexity with these sorts of things. So I just kind of went my own route and like, screw it. I'm not going to try to use their terms. I'm going to use my own. And then with the communication systems, same exact sort of thing. I just made up words. And here, literally, it's just glossolalia. I just stuck sounds together in a pronounceable sort of form. So they don't mean anything. They don't come from anywhere. There's no etymology to this other than I needed a term, and I just made one up. And I feel like there's value in this because it's not ever going to be conflated with what somebody else is saying. Because I invented this term. This is what it means. If you don't like it, if you don't agree with it, just don't use the term. No problem. So the simplest one. This one is only utilizing Genevieve, and it is called Jarvan. So that is going to be basically like instinct sort of things, right? So little baby quail, how they sing like a finch when they're little, and they know to peck at things that look like sand to get food, and they know, like, as soon as they hatch, they know how to find and drink water. Like, these things are amazing. It's definitely innate. That's Jarvan. Yeah, like the communication systems, right? So some of this is kind of like the environment is communicating to them, right? They see like a gravelly surface, and they know to peck at that to find food in that. It's just, if you've ever raised birds, that's amazing. As soon as this little bastard can barely walk, he's doing that. It's like, wow, how do you know to do that? Yeah. Or their chirps, right? They have like a panic chirp and they have a comfort chirp, and you know, that sort of thing that is much more clearly in the linguistic sort of domain. That's Jarvan. I would not ever call that language. Language we'll get to at the very end. It has a specific definition. It is distinct from all of these other things. All right, so Jarvan, like the communication systems of frogs. They don't seem to learn anything. They just, you can just raise a tadpole, it'll grow up, and it'll be talking exactly the same as the population, the wild population that it has been completely isolated from its entire life. They communicate exactly the same way. So that is Jarvan. It is completely innate morphology. It is not programmable. It's just occurring because they feel like, something in the environment stimulated them. They are, they're at sexual maturity. It's the right humidity. It's day length is, whatever it is. That sort of thing. It's triggering it. They do their thing. Let's see. So the next one, that is a type 3, right? That's going to have a grammar type of 3. The next one, Finrank. So this one, in my notes here, I only have it attested in arthropods. Particularly things like eusocial bees, eusocial insects. And this one, because this isn't really based on my own research, my own observations, it's kind of based on what other people have said, and I haven't actually this one I don't have a lot of confidence in. But, so, really all of them, they're going to involve the Genevieve with innate morphemes. That's always a thing, right? There's always things that have to be instinctual. So that it has that. The thing that it adds is Eleanor for handling. So the morphemes are Genevieve. The morphemes are innate. The signals themselves are innate. But Eleanor is potentially, based on what I have seen talked about, the way that these morphemes combine. Right? So we have an ability to concatenate and get larger structures out of these innate morphemes, and the way that they combine can tell you something new. So I think the idea here was looking at how bees can communicate the location of a pollen source. All of the component parts of their communication there are innate, but the combination is programmable. Right? The bee went out, found something, came back. It has some record of the details of that, so that was programmed, and then it's able to communicate that program via these innate morphemes. That's all that FinRank is. I believe that's attested, but again, it wasn't my own research, so sort of speculation. The next one, so yeah, so that's in arthropods, that's in bugs. It might be in other things, it probably is, something like that. The mammalian equivalent of this, I called Hukmo, and this is, you take Genevieve with the innate morphemes, so like frog language, the instinctual sort of things, and you add onto it Eleanor for handling morpheme semantics. So this is attested in prairie dogs. So basically, what this is you have the instinctual, like the sexual signals and things like that, like hierarchical, like I'm in charge and you're just a peon. That sort of those signals, that's handled by Genevieve. But then you have Eleanor handling. You can bring in other signals. You can make up names for things, basically. So you can name a coyote, you can name a hawk, you can name a human being, and you can talk about, oh, that person has a red shirt, and that person has a blue shirt, and that person is tall, and that coyote is mangy, and like there has been research on prairie dog communication that indicates that they're able to do this. And again, it's maybe just one or two of these morphemes, and usually they're repeated 2 or 3 times. But they can be concatenated together. And yeah, so that's the idea there. You have Eleanor handling the programmability of the morpheme semantics. And then the avian analogy to this is, so all of these, they have distinct evolutionary paths, right? So the bird version of this is you have Genevieve again handling the instinctual stuff. But then morpheme form. So that is going to be right. So with the prairie dogs, the form is consistent, right? You can this little sound, but it's going to repeat a couple times, and then you can stick it onto another one that's repeated a couple times. So the form of it is consistent. With the birds, the form is the thing that you can adjust. I'm actually questioning this at this point. What was I talking about with that? Because I use mockingbirds, but mockingbirds, the form is actually stable. Anyway. That was the idea. And the bird one I called Humkuk, but yeah, I'm questioning it now, so hey, whatever. But yeah, kind of the important thing, like what I was looking at is you got bugs and you got birds and you've got mammals and they all communicate, but they would have had different evolutionary paths, so possibly different things are happening here. And, my conclusions, this is from several years ago, they could be wrong. I don't understand what I was talking about here, so hey. I think maybe okay. Maybe what I was meaning here. So the mockingbirds, they learn a little snippet of song, of some some sound, like a car alarm or some little finch or whatever, and they map it onto usually they'll repeat it 3 times and then go on to something else and to go on to something else and go on to something else, but it's 3 times each, right? So there's a form there that is systematic. But the details of the signal that you're mapping onto this form are much more variable than with the prairie dog thing. So that might be what I was talking about. Anyway. Let's see. So there's a couple more here. Kind of the next the next step up from Hukmu, so that's the mammalian. It's still type 3. It's still handling type 3 grammars. Um, the next step up from Hukmu, which is the mammalian form that involves Genevieve and Eleanor, where Eleanor is handling morpheme semantics. Yeah, okay, so that's what it is. Yeah. So with the prairie dogs, the signals they have different meanings. With the mockingbirds, it doesn't have a different meaning. It just has a different shape. It just, yeah. And that's overlaid onto an innate shape that's handled by Genevieve. Okay, so that's what I was talking about. So it does actually make sense. Okay, so the next step up in mammalian, based on what I have, and I probably missed stuff, right? So don't take this as, the end of. This is early research that I did individually on my own. Nobody helped me. Nobody was interested in helping me. I asked a few people to try to help me, and they just kind of looked at me like, "What the f are you talking about?" So it's all just my own work from a few years ago. I don't remember it all that well, clearly, as you can see. So, yeah. This is just levels that I did see that I think kind of justify the three computational levels that I came up with in evolutionary terms. So the next one for mammals, so the basis that this is growing from has Genevieve handling instinctual stuff, Eleanor handling semantics, so we're able to make up words for new things. That's what that is. And this one is tested in animals like chimps and orangutans, so really the great apes, including humans, but we go a step further than this. Actually, we go a couple steps further than this. But yeah, so the great apes have this. Probably, I wouldn't be surprised if some other animals have it, but it definitely seems to be in the data when you look at, from like Coco and Nim Chimpsky, these guys, where you're teaching them sign language, and if you actually look at the structure of what they're doing, this appears to be what's attested. So that's where this is coming from. The name that I gave this one is Farlak. So the basis is Genevieve for the innate morphemes, Eleanor for the morpheme semantics, and then Eleanor comes in again handling morpheme union. So with like the prairie dog, you seem to kind of you're only able to take, you have these signals that indicate something, something that you can learn the meaning of, right? So like a red shirt person, right? Tall person, right? But you can really only do this, you can only have like one concatenation event, right? You can only stick two together, or maybe a few more, but it's very, very limited, right? You kind of just bam, bam, maybe bam, 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 depending on the species. And I think the data that I've seen is really just pairs, but that doesn't mean that it can't go further than that. But the order might be strict. Maybe. I don't remember. It might be. But with chimps, so if and gorillas and so the great apes, when you look at their sign language, they kind of just keep sticking stuff together for a minute. And it's definitely not language, right? It doesn't have the right structure to be language. It's absolutely not language. But it is meaningful, and they are pulling in easily 4, 5, 6 different words and just kind of smashing them together, putting them all into this string. It'll say like nim, banana, nim, want, banana, nim, now. Something like that. Like, it's not language. It's clearly not language, but we're able to make longer structures involving more words. So you get Eleanor is able to handle more. It's not just that we're able to name things. We're able to name things and stick a longer string together from these names. And the order doesn't necessarily matter, right? So that's the That's the mammalian version. So the mammals will have gone through Jarban, Hukmu, and Farlek up to this point, and then the avian equivalent to this, which I haven't found attested anywhere, so it's hypothetical. Um, Also includes morpheme semantics. So it's at this point very similar. Um, but then you go one step further, and that one was called Farlcook. Just a moment. All right, so Farlcook handles Genevieve handles innate morphemes. Eleanor handles morpheme form. So that is Humcook, and then one step further, Eleanor is handling morpheme semantics, just like Hukmu did with prairie dogs. So you're able to name things and call out those names. This is a little bit, because it's a communication system. It's not We're not talking about the ability to learn that a signal refers to something. So, with a rabbit, you can. They're going to be like the prairie dog. They're going to have Hukmo, but you can teach them that a signal means something, but they can't necessarily produce that signal. Right. So it doesn't work as a two-way communication system for them necessarily. Right. So that's what the morpheme semantics is. So at that level, I don't know of any examples in birds, but so it's a kind of a hypothetical. But if we take that and add onto it the morpheme union thing that Farlek is involving with chimps, then it is suddenly attested, and that's going to be in things like ravens and parrots, and the psittacopasserines, or some of the psittacopasserines at the very least. So that one I called Farlquat, and that one is attested. And all of these that I have mentioned are still type 3 grammars. Right? So I have a huge diversity of communication systems that are clearly different from each other. But under the Chomsky hierarchy, they're indistinguishable from each other. So, yeah, I find that quite fascinating. So the Farquaad is the avian version. So up to this point, birds have gone through Jarban, Humkok, which is Jarban plus the ability to kind of change the sounds that are involved, but it's still an innate sort of signal. It's mapped onto an innate structure. So like Mockingbird song is like this. And then Farlcook, which takes that and adds onto it the ability to adjust the semantics. So you can name things and you can refer to things. And then one step beyond that is Farlquat, and that allows you to take those and concatenate them, and somewhat arbitrarily. So listening to things like even like finches, sparrows. I think sparrows. I can't. Whatever. Little house sparrows. Yeah, those little guys. Listening to their song, if you're paying really close attention, a lot of it is kind of Jarban level. It's innate stuff, but then there's another level to it where they seem to be kind of made up their own terms for stuff, and they're able to just kind of string them together. If you listen to different populations, they'll be different. So presumably there would be dialects, and one coming into another area would have an accent, and all this sort of interesting linguistic-y sort of stuff. We're not dealing with language yet. Formally, this isn't language. There is no syntax, but we're able to take words and kind of stick them together and get larger meanings from that. But the order doesn't necessarily, at least as far as is demonstrated, the order doesn't seem to matter, right? So you can have these three terms and you can arrange them in any possible way, and all of those will end up resulting in the same meaning. And then the The human equivalent of Farquaad is Purquat. So this is only tested in humans that I'm aware of. And it's also still not language. So it has the 4 levels. It's got Genevieve, basically Jarban, and then you've got the added morpheme form, which gives you Humkuk, and then you've got the added morpheme unions. Let's see, yeah, morpheme unions, which is Farlak. So we're growing. This is the mammalian lineage, and then you add one more morpheme form. So this is you're able to change the signal, the what is happening here? Morpheme form. Okay, so there's structures, and you're able to manipulate what's happening on top of that. This is going to be in pigeons. So this is not something that humans really like to do, but it is a thing that we do sometimes when we have to. So a pigeon is basically a sort of grammarless mixture of a couple languages, right? It doesn't have a systematic syntax yet. It's kind of that early in that first generation of contact between two people that are trying to communicate with each other, and you kind of just throw words at the wall and hope that they understand what the hell you're trying to say, right? So it ends up looking very much like Nim Chimpsky's and Coco's sign language. It looks very much like that, but it is a little bit more complicated than that. It is a little bit more capable. Still type 3 grammar though. So all of these up to this point, there's 1, 2, 3, 4, 5, 6, 7, 8 that I've talked about. All of them are type 3 grammars. So under the Chomsky hierarchy, you could not discern these from each other, which is probably why I had to come and make up terms for all of them, because I don't know that they've been discerned by anybody. And then there is an unattested level. Suddenly we're at type 1. So this one it's sort of analogous to Pulquat. It is a possible branch from Farlak that appears to have not occurred. Or it might have occurred and died off. So this, like, Namquat might be something that, like Paranthropus had, or something like that. Entirely possible, but it for whatever reason, it was not sufficient and it died off. Or I might have just not seen it in the data, and it might be a thing that we do. So this one, Namquat, unattested. It would also probably be in human ancestors, like relatively recent human ancestors, since our split with chimpanzees, since our split with Pan. So this one does not have morpheme form, but it does have displacement. So Emily is coming into play here and handling syntax. So that is where I mentioned it in another video. Basically, you have a string, and you have multiple tokens. So so this is time. So this is where we start and we end down here, right? So I drop in, words basically, and I'm able to make connections between words that are not right next to each other. This is what makes Turing completeness. Basically, this is what kind of finishes it off and gives you that ability to handle Turing complete instruction sets, is that ability to go back, right? So, like, what are you doing? Doing is resolved, or is the resolution of the scope opened by what? And then are you is signal that's occurring, it's intervening. So we have to be able to process this independently of this, and then this we have to recognize, this closes that scope, and then we have to take what these two are doing together and then combine it with what these two are doing together, and that's syntax. If it's just word, and like each pair is kind of resolving, then that's not syntax, right? So I am washing the dishes. There's no syntax in that because it's just a serial resolution. It just cascades. The resolution's just bam, 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 bam. Simple. There is no, there is no reason to have to like store the signal and then go back into parts of it and handle it. That's complicated. That's a difficult thing to do, and you actually find even in human languages we don't do that very much. All right, we are capable of doing it, but it is a difficult thing to do. So languages are actually designed to sort of minimize the need to do that. Um, yeah, so Numquat has that ability, but it lacks things that pigeons have. So you kind of it's not attested. I haven't seen evidence that it exists, but that one would be type 1. It may never have existed, it may never have happened, I have no idea. Um, yeah. And then language is basically pigeons, it's Pulquat with the displacement added on. So this is things like English, Chinese, C++, COBOL, mathematics. These are languages. They have syntax. Something can happen early in the signal, and it refers to something later on in the signal, and there's intervening signal that's in the way that you have to deal with before you can resolve that first thing. That's syntax. That's what makes it a language. As far as I'm concerned, that's what makes it type 1. Feel free to disagree with that. And then in formal linguistics, there is a further level, which ironically, Noam Chomsky, it's his baby, but ironically, he seems to have not recognized what it is. Right, so he has type 3, type 2, type 1, and type 0. Type 3 being, finite state automata. Type 2 being push down automata, so like stacks. And type 1 being linear bounded automata, so a computer or a human brain or something like that. Something that is capable of handling, at least hypothetically, handling any computable function in a realizable sort of time frame and resource allotment. And then type 0 just relieves you from the time frame and the resource allotment. Right, so you have infinite time available, you have infinite resources available. You can do so anything that could compute, that would be a universal Turing machine. But then there is one step further that Noam Chomsky proposed, his universal grammar. It is not physically realizable when you look at the details of the proposition, so it is actually an oracle machine, which is a type that Chomsky did not talk about. He ignored it. But it is laid out in the source material that Chomsky looked at in order to build up his ideas. So it is knowable for him all along. He could have recognized this problem, but as far as I can tell, he didn't, and nobody else seems to really have either. Criticisms against Chomsky's linguistics never seems to notice this. So I might be the only person who's saying this. I don't know. But basically, UG, universal grammar, is physically impossible. It cannot be a real mechanism because it invokes magic. It's a supernatural sort of mechanism that makes it an oracle machine. It's able to compute uncomputable things. And I've seen that almost said. So there might just be misinterpretation on my part. There could very possibly be people who have actually said this correctly, and I just didn't understand the way that they were phrasing it. That's fine. But so I have the three sisters of computational complexity attested in animals in evolutionary terms: Genevieve, Eleanor, and Emily. These two guys are finite state automata, Genevieve and Eleanor. Emily is a finite or a linear bounded automaton, and then the fourth sister, Lilith, is what UG is, and that is an oracle machine, basically a magic. So that's kind of an outline of my analysis of communication types. And as I said, it is coarse grained. It is based on a lot of other people's research, some of which was of quality that I'm not comfortable with. So you know, I am not confident that this is true, that this is accurate. But as far as a jumping off point, I think it's a fair place to start. Because I do have some amount of detail resolved in there, and you can go back and look at data and say, well, no, you're completely wrong about this one. You're completely wrong about that one. Oh, this is good, but we need to develop it more. Things like that. So, yeah, that's where we're at.